Welcome back to the 30th part of Debugging at Scale, where we try to understand the nuance of failure. The discussion of failure is often very binary. Code fails or succeeds. There's a crash or it works. This is a very problematic state of mind. A crash or downtime is bad, but by no means is it the only type of failure, or even the worst type of failure. Crash usually marks a problem we can fix and even work around by spinning up a new server instance automatically. This is a failure we can handle relatively elegantly. The whole industry of orchestration was designed to handle just this type of failure. Data corruption is far more sinister failure. A bug can result in bad data making its way into the database and potentially causing long-term problems. Such a corruption can have widespread impact on security and reliability due to corrupted data. These types of problems are much harder to fix as it requires reworking the data, which might be unrecoverable. A fail-fast system can sometimes nip such issues in the bud. With cloud computing, we're seeing a rise in defensive programming, such as circuit breakers, retries, etc. This is unavoidable as the assumption behind these solutions is that everything in the cloud can fail. An important part of good QA process is long-running tests that take hours to run and stress the system. When reviewing the logs of these tests, we can sometimes notice issues that didn't fail but conflict with our assumptions about the system. This can help find the insidious bugs that went through. Don't fix the bug right away. Well, unless it's in production, obviously. We should understand bugs before we fix them. Why didn't the testing process find it? Is it a cascading effect or is it missing test coverage? How did we miss that? When developers resolve a bug, they should be able to answer that question on the issue tracker. Then comes the hard problem, finding the root cause of the failure and fixing the process so such issues won't happen again. This is obviously an extreme approach to take on every bug, so we need to apply some discretion when we pick the bugs to focus on. But this must always apply to a bug in production. We must investigate bugs in production thoroughly, since failure in the cloud can be very problematic for the business, especially when experiencing exponential growth. Now that we have a general sense of the subject, let's get into the more practical aspects of a course focused on debugging. There's no special innovation here. Debugging a fail-fast system is pretty darn easy. But there are some gotchas, tips, and tricks we can use to promote fail-fast. There are other strategies we can use to debug a fail-safe system. To ensure a fail-fast system, use the following strategies. For exceptions, define the contract of every API in the documentation and fail immediately if the API is invoked with out of bounds state, value, etc. Enforce the strategy with unit tests. Go over every statement made in the documentation for every API. Write a test that enforces that behavior. If you rely on external sources, create tests for unreliable situations, low performance, and sudden unavailability. Define load timeouts. Never retry. The core idea is to fail quickly. Let's say we need to invoke a web service. A networking issue can trigger a failure. A fail-fast system will expect failure and present an error to the user. For fail-safe, the core idea isn't so much to avoid failure as it's unavoidable. The core idea is to soften the blow of a failure. For instance, we take the web service example again. A fail-safe environment could cache responses from the service and would try to show an older response. We can build a test case to validate that behavior. The problem here is that users might get out-of-date information, and this might cause a cascading effect. It might mean it will take us longer to find the problem and fix it, since the system might seem in order. The obvious tip here is to log an alert on every failure and mitigation so we can address them. But there's another hybrid approach that isn't as common but might be interesting to some. A hybrid fail-safe environment starts as a fail-fast environment. This is also true for the testing environment and staging. The core innovation is wrappers that enclose individual components and provide fail-safe layer. When a system is nearing production, we need to review the fault points within the system, focusing on external dependencies but also on internal components. A fail-safe wrapper can retry the operation and can implement recovery policies. There's some ready-made software tools that let us define fail-safe strategies after the fact. For instance, fail-safe, Spring Retry, and many other such tools. Some of these tools are at SaaS API levels and can mitigate availability or networking issues. This has the downside of adding a production component that's mostly missing in development and QA, but it includes many of the advantages of fail-fast and keeps the code relatively clean. This approach has some drawbacks when it comes to debugging. Fail-safe behavior is encapsulated by libraries and can be hidden. When something fails and then retries, we can lose some context information. This is further compounded by the differences between production and development environments. While this isn't an ideal approach, I would pick it for a case where I need fail-safe support. We covered three very different subjects in this module, but there's one surrounding theme. Debugging starts when you write the code. The choices you make as you start will impact your debugging experience moving forward. Logging, testing, and architecture decisions such as fail-fast policy all have long-term implications. I hope this module will help you focus on the practices listed here and help you make more conscious decisions. If you don't have a logging best practices document, make sure to add one. If your unit tests aren't focused on enforcing policies such as fail-fast or fail-safe, they probably should. If your tests are flaky, you should take them this seriously. That might be a bad omen. Next, we'll start digging into Kubernetes debugging in Module 5. If you have any questions, please use the Slack channel to ask them. Thank you.